a light review on factoring and completing the square. Okay?
Okay.
Okay, so first off, we're given an equation like this. You all know what to do, right? Two numbers that multiply to 4 and add to 4. Plus 2x plus 2x. I'm just breaking this 4x into a sum of the two.
Yep.
Plus 4. We are left with x plus 2. Okay? This can be rewritten as x plus 2 squared. Correct? Now, what if we don't have as easy of a problem? What if we have a problem like a little bit more difficult, right? Okay. So, on this one, I'm going to ask that we complete the square on this.
Okay.
Does everybody remember how to do that? Okay. So, first thing we're going to do is take 10, which is our b. We're going to take 10, we're going to divide by 2, we get 5. We're going to square 5, we get 25. We're going to see how I'm completing the square? These are the steps that you need to take in completing the square. We get 25, we're going to add 25 and subtract 25 because we do not want to mess up our original equation. We want to keep it the same. So 25 minus 25 is 0. So we're keeping it all the same as this. I'm going to take this positive 25. I'm going to write it on the other side of 23. This is a list of vocabulary words and an activity we're going to do later. The vocabulary words, in just a moment when you think about what those terms can mean. Okay? Don't write it down just yet. Vertex, okay? This one right here. In a vertex, let's get a different color here. I'm going to rewrite this equation up here, okay? All right. This right here, this equation is called the vertex form, okay? Why do you think it's called the vertex form? Why is the point slope form called the point slope form? Because you can identify the slope and you can identify your slope or your points, right?
Yes.
Okay. Well, this one is going to be so we can identify our vertex. Well, what's a vertex? A vertex is this is roughly what a quadratic equation looks like. There are a lot of rules and a lot of things that make it go up or down or sideways, left, right, anything you want, okay? For the most part, on all quadratic equations, there is this point or this point, which is called the vertex, okay? You can think of this as a minimum or as a maximum, okay? All right, in motion and maybe like in physics, we look at equations, quadratic equations, to identify where an object goes, okay? Sometimes an object can go up, but it's going to eventually come back down due to what? Gravity, exactly. So when we look at this height, if I throw something from the ground up or anything from the ground up, this point right here is going to be its maximum height, right? It's going to be how far up it goes, okay? Sometimes we have like pendulums or we'll have something moving where we can determine a low, right? Here's a low. This is going to be the minimum. We can also look at this like maybe in terms of finances or in terms of trying to get a certain amount of feet in a certain area, okay? We can try and find the minimum number of feet within that area to try and contain something. If you only have so much fencing to create a land or something to put horses in or something like that, it can help, make sure that you live within your means of your budget so that you have the minimum amount possible, okay? This is just in terms of a quadratic equation. So vertex is very important. The way we identify a vertex in vertex form is similar to how we identify points or y-intercepts and things like that, okay? In vertex form, we're going to look at this number right here and this number right here, okay? This number right here, -5, when x plus 5 equals 0, x equals -5, correct? The y is just going to stay the same. So our vertex in this equation is -5, -2. Now, if this number right here in front of the equation is positive, which technically there's a little +1 hanging out right here, okay? Then it's going to open up. If this number is negative, then it will open down, okay? So for right now, we're just going to deal with up and down quadratic equations. Later on, we'll deal with left and right opening quadratic equations. So for this one, it opens up, and our vertex is at -5, -2. So I go over 5, and I go down 2. That's where my vertex is. Now I said it opens up, right? Now this is a very rough sketch of what this quadratic equation looks like. We can identify these 2 points, can't we? How? By factoring and solving for x, right? Well, we already said that this was a little too difficult to factor. Well, there are going to be 2 roots to this, and the way we find this out is our lovely dovely quadratic equation. All right, for quadratic formula. Now, does everybody know the quadratic equation? I remember it as Pop Goes the Weasel. X equals -b plus or minus square root b squared minus 4ac all over 2a. Perfect, right? Awesome. All right. So what is our b? Let's label everything.
Yeah.
A equals 1, b equals, and c equals. All right, let's plug these in.
There's 1.
Okay, this is gonna work. All right.
So.
$92.
I don't know what the square root of 92 is.
Now we go -10 plus or minus square root of 8 over 2.
Yeah, that makes sense.
-5 plus or minus 2 square root of 2.
Yep.
Okay. So now we have our 2 x's. We have -5 plus 2 square root of 2 and -5 minus 2 square root of 2. Okay. Who can tell me? Here, I'm going to give out calculators.
Okay.
What square root of 2 is? An estimated guess of what square root of 2 is.
1 point something very small.
1.14, something like that, right? So this is almost like 2 times 1/2. 1.5. Okay? So negative 5 plus about 2. My goal is to get you to understand the concept of this, to understand that this is the vertex and these are the x-intercepts. Okay? Now, we also have a y-intercept, which is also important in a quadratic equation. Can you identify, you looking at this equation, what the y-intercept is? 23. Absolutely. So all the way up here, it's going to keep going and going. This number is 23. This number, that's where that number is going to hit that. I cannot be lower than negative 2, correct? What is my minimum of this function?
Negative.
Negative 2. Absolutely. When x equals? Perfect. Awesome. All right. This is not drawn to scale, but what I want you to do on your papers is I want you to look at this ball.
Mm-hmm.
I want you to see how high it goes. Write it down on your paper. And I also want you to write what the graph looks like, what the path of the ball looks like as it goes up and it comes back down. Okay? I'm just going to throw it lightly. The reason why we're looking for vertexes is you all should have drawn a graph that looks similar to this right here. Okay? This is the maximum height, which you say is 7. Okay? Now, if I said that we have to have factors into this, right? I threw a ball with certain force and certain speed that went up and down. If I threw it a little lighter, it wouldn't have gone as high, right? Gravity also plays an effect on the ball, okay? So when we write a quadratic equation, right, gravity has to have something to do with that. It has to be a variable in that equation, right? And also our height, right? Because if I throw it from down here and give it the same that I did before, it's not going to go as high. Does that make sense? Okay. I also have to throw it with enough velocity, with enough speed to push it up that high. Okay? So those 3 things, height, speed, and gravity, have to do with a quadratic equation. Okay? And they have a variable put onto an object as we're talking. Everybody get out their calculators. I'm going to show you how to do this graphically, and then I want you to practice with your partner on how to enter it into your calculator. So first, make sure your home screen is blank, okay?
Mm-hmm.
We're going to hit the y equals button, okay? Everybody enter that? I want you to graph this equation, okay? What we do is there's an X button right above the apps button. It also may be next to the alpha button. Do you see it? Okay, push that. Okay. There's also a squared button. It says X squared right there. If you push that, that gives us our X squared button. Now make sure that you enter these in right, okay? We have to remember about PEMDAS, right? Or order of operations. Perfect. Now, we've entered in this part. Plus 5x. Plus 5, hit that X button. Plus 10. Now, hit the graph button.
Got it.
And you should have something that looks like this. You have that on your calculator? Perfect. Now, we look at this and we know that, well, if I'm trying to evaluate my vertexes, I'm trying to evaluate a y-intercept. Let's say this is a very complicated problem. Well, we can look and see and kind of check our work and see that if this is the right number that we're used to. We can zoom in, we can zoom out, and there's all kinds of great things that we can do. For now, I just want you to know how to graph it in your calculator. Okay? Now, I want you to graph this in your calculator. Okay? If we go to our y equals button, we want to enter it exactly how it is, okay? When I say this out loud, it's x plus 5, the quantity squared, okay? Plus 1. We enter in with our parentheses, there are parenthesis buttons. X plus 5, close our parentheses, square it, okay, and then plus 1.
Mm-hmm.
That's what it should look like on your calculator. About right? Perfect. Now get with your partner, and I want you to practice what's on your worksheet, telling your partner exactly what's on your paper, enter into the calculator, then switch, and have the partner tell you what to enter in your calculator, and make sure that you both have the same thing in your calculator.